I currently work for Booz Allen Hamilton, and I've been using Scala for about a year now. I was a big Java developer back in the day and started with Play 1 back when Scala was just a package. And as they expanded to Play 2, I kind of got the Scala bug, and I've caught it and been ever since. So just a few questions to you guys as the audience so I can kind of gear my talk. Please feel free to encourage. They're not hard questions. First off, who went to Josh's talk earlier today? All right, that's what I was scared of. Not really. So he had a nice talk on futures, which is one of my main topics of what I was going to cover today. But I'll kind of fast forward through that part and kind of explore some other aspects of play that I really like. So my next question is, has anybody ever used or seen of Play Framework before? All right, awesome. Now, who has put a website online with said Play Framework? All right, sweet. So we got a lot of people who are comfortable out there, and I'm sure you guys have used Akka, which is a pretty sweet package that is on the TypeSafe platform. So I'm going to go ahead and just give you a little overview of my talk. This is about just building the web service for a common man. A lot of the talks we've seen today are these very big optimizations. And so I kind of want to take a step back from it and kind of say, hey, this is how you start, and then build your web services, and then hopefully we can get to the point where a Hadoop cluster would be kind of cool. But you can't really, when you build your startup, you can't really do that at the very beginning. So first, the basics, async versus blocking I/O, right? So one of the cool things that Scala allows you to do is to create these really nice callbacks. If you have ever seen a Node.js application, you understand the callback hell that exists, right? So what the map functions and all of these callback functions really make it nice and easy for you to create really consistent and clean code. So what we're trying to prevent here is to kind of create this non-blocking area. So you can see on the left, with the red side, you have to wait for your web service to come back for you, even before your database call, right? Because database calls, at least for most of the, well, at least this is stuff that I use, we use a JDBC, and that is blocking. So on the right, you can obviously see you're going to save yourself a good percentage of time. Right. So Play Framework, I'll go through this quick because most of you guys have done it. One of the major features I loved about it was the one-click reload. It will recompile your app for you on the fly through the browser. It comes out of the box with all these cool features like less, CoffeeScript, the fun stuff that make web development what we all know and love. It's done by TypeSafe. They've done a hell of a good job, especially over the last week. They released 2.1, which is a huge milestone, as well as Slick 1 as well. So there's been a huge updates, and it's really cool to see them doing their work, and I thank them immensely. So a quick demo here. So I kind of created like a little here you go demo of how to create a simple web service. So if the internet works, what it's doing is it's fetching a web service. It's actually really slow, and that's actually pretty cool that I kind of made it so it's safe. It's not going to throw an error back on our system, and I'll show you the code in a little bit. But basically it says, oops, our currency service has failed, sorry. So one of the main features that I really liked about Scala and the Play Framework especially was that it was very easy to make it very safe. You kind of caught your errors whether you needed to, you can make your fallbacks, you can be repetitive if you wanted to. But at the same time, it wasn't too excessive, it wasn't too verbose. So, so that's just a cool little demo, and we'll kind of go into that in a bunch more detail. Okay, so let's review some definitions. Threads, as Josh said before, these are your single blocks of instructions that are computed, right? So you can have many processes, or you can have a process that contains many threads, and you can have these pools of threads, right? These are called execution contexts, and we'll go over this in a little bit. But these are what actually runs and computes your code. Future, right? So a placeholder which represents a value which may become available at another point. So Josh, again, did a really good job at covering this today and explained to you the basic functions. But I just wanted to kind of show you some of the functions in the trait from Scala source, because there are some rather interesting things, especially when it comes to failing over. So in the second section, the first section was pretty easy. It's pretty self-explanatory. Can you guys see it in the back? Ish? No? Okay. Better? Okay. Maybe it's a little better. I have good eyes. I apologize. So the cool thing is failed and recover. It's a very nice way of checking to see, obviously, if your future has failed, and if you recover, what you should recover with. Now, the partial function, right, that is being brought into the recover function is really what you can use, and you can adapt that to any way that you want. Some common methods I've seen are 3-time retry. So if you can retry it 3 times, and if they all fail, then you can handle it some way else. Or you can just throw a failure and have the user retry. It's really up to you. So that's a future. A simple example of a future, Josh kind of went over this, so I'll skip it. A promise. A promise is a placeholder which contains a future. So it's kind of one of these things that you can use as like an interceptor. You can complete a future with, so a promise, when you declare a promise, you can then gather its future. So Josh didn't really cover this earlier, so I'm going to go over it a little bit. So you have a future, right? Your computation of a Fibonacci number, and you have your promise, right? And you say, you map your promise to your future, right? And you say the future on success, right? That's normal. But let's just say you want it a little more creative and you wanted to have some other function that may intercept it. You could say p.fail, or you can do many other things with the promise, and you could pass the promise around instead of the future. Okay, execution contexts. These are your containers of your threads, similar to a process, but not really. You can create them in a various different manners. So when you create your context pool, what you can do is you create your context, and you can pass this context around. So I'm going to show you guys a little bit of this in the source code. Can you guys see in the back? All right, we're going to be scrolling a lot today. So we have our execution context, right? Now I want to keep my database calls separate from my CPU heavy calls, right? Because their database calls are blocking, right? So I can handle it a little differently and manage my threads a little differently than if I were to have some very computational heavy, let's just say, calculation calls, right? So you create your execution context, and then you create a new scheduled thread pool, and you say how many, so this number right here is 10. So I said I want 10 threads. And instead of scrolling up there, I'm going to zoom it, and it should work. All right, cool. So you can control how many threads you actually create in a given thread pool and in your execution context. So one thing to keep in mind when you are creating these threads and the thread pool is that you really can't overload it, right? Threads are not these magical things that you can just change every time. Every time you swap a thread, there's a context switch in the processor, which has overhead in itself. So the more things you have going at one time, the more things get multiplexed through the pipeline processor, and there's more switches. So at a certain point, if you overload your machine, you'll end up seeing that most of your computer processing time is actually switching between your threads as actually opposed to doing your threads. So when you design your system, you need to be a little bit careful about what you're doing. Some rule of thumbs that I have that have been fine for me, I'm not a Twitter, so I don't have these huge load things and no Tumblr. But as I've used about 10 per core and then about 3 execution contexts, and that's worked very well for me. I haven't had too much overhead in terms of switching, and it's worked rather well. Okay. So, whoops, not that. So actors, right? Some people have touched on this a little bit before, but what actors are a nice abstraction for creating futures and different asynchronous computations, right? So they're very, the ACA gives us a really nice API to work on, and you can create lots of them and network them in a pretty nice tree. So the fault tolerance is one of the main features that I really enjoy about ACA, and that is that I think it falls under the supervisor pattern. That's what generally works best. Basically, what that means is that as you create your different application, you can create a supervisor that basically supervises all of your, let's say, worker nodes, and if one of those fails, they'll send a message back up to the supervisor, and the supervisor can handle it. So you're not handling errors within the specific worker node, but you can handle it from above. And it really provides a nice, clean, and elegant way of creating code without actually having to handle each error case in the specific number crunch. We'll go into that a little more. So obviously as Josh mentioned before, for comprehensions are one of your best friends. They are really nice when you chain a given future. So you can, instead of having to say, let's wait for this to come or zip them together, this is another alternative. So one thing to note here is, so let me go through this example line by line, and sorry for you guys who already know play, but for those of you guys who don't, this is in a controller, okay? In the MVC pattern, I hope, if you guys are not familiar with it, it's basically the thing that executes our code from the very beginning. So the action is called, right? And async, these tags basically notify play that it is an asynchronous tag and that it will return a future result instead of an actual result. So basically what it's doing is it's just adding it into a closure and running it as such. So you can do recent posts.recent, right? And then you can take the tags and then calculate a word cloud from it, and then you yield your result. And you can yield different results like OK, internal server errors, etc. So one thing that I really like to do in this, so in the little post, and you saw the error, right? So what I did here is we have so the account function is what I actually called that you saw that error. If my internet was working, what you'd see is I have these bank accounts and I converted it into euros, right? So I called this web service that would take a currency and it would give me a rate. So this is a little fault tolerant service, right? So you have your account, which you find from a database, and you find your rate, which is a service. One thing to note here is this fallback to. That's basically the bread and butter of the fault tolerance on this simple level. So basically, if the future fails, right? So the Play Framework web service is actually built asynchronously, so it handles very nice with the future. It actually only returns the future, and you would have to either await for a result, which is a blocking operation, or you can have it mapped to a future. So I actually fall back to a future of none, right? So if I have the account, right, and I say, okay, no accounts found because I don't have an account. Or if I have an account and I have some account instance and I have a rate and I actually have a rate, I can convert it. I can basically say, hey, the account, put it in the currency, and then return it back to the user. Otherwise, if I don't have a account, I return a bad request, and I say our currency service has failed. Sorry, chaps. So that's a pretty easy way of doing some simple fault tolerance. So let's do another demo real quick. so building asynchronous web services are cool, but one of the, I think the biggest things in applications nowadays are WebSockets and real-time single-page applications. So everybody's heard of WebSockets, right? Okay. Do you guys know what so basically there's also this thing called Comet, which is for browsers that are old, which none of us like to develop for, but is a sad reality, and especially for the government, you have to use this stuff. So some reason they're stuck in IE7. Don't ask me why. Anyways, Comet provides a really cool way of you literally just inject JavaScript onto your DOM, and then it'll execute. So in this simple application, I can just post, and it fetches it live from the database, right? So that's why I'll show you the code real quick. Where is it? One second. Wrong package. Okay. So here is the dashboard stream, right? So that's what we're invoking at the very beginning to basically call this Comet service, right? And we are streaming back results. This is not a polling service, right? So it's actually a chunked HTTP request that's always loading, right? You'll notice in the top left corner of the dashboard that it's always reloading, right? It's one of the fallbacks of the Comet thing. You can't have your cool favicon on there. There are workarounds, but out of the box, it's just not worth it. So it's literally just keep on. It's having a chunked one huge request that keeps on coming in. It's similar to what Twitter does when they feed you your feed. So in our stream, right, we have our enumerators, which produce the given feedback, right? So let's go back and say in our stream, we want to see the transactions amounts. We want to update the balances, and we want to get a transaction total, right? And we feed this all to our Comet, which is actually provided by Play Framework, to parent.dashboard.message. Now, this callback is actually a JavaScript function that you build on your client side that basically figures out how to consume the given inputs, right? Because what the Comet does is, at least in the way that I built this system, is that it composes this huge string and then throws it to the client, and the client parses it and then updates the DOM appropriately. So enumerators are, have you guys ever heard of enumerators and iterates a little bit? If you haven't heard of it, Clout made a really awesome blog post about 3 weeks ago that really kind of broke down how they work. But basically, an enumerator is like a producer, and an iterate is a consumer. And instead of having to rebuild stuff every time you want to fetch something, they're kind of there, and you can just get what you want at the rate you want it. So in our enumerators, you can actually, so I kind of say, and I build these strings, they get sent over. So that's the Comet way of doing things. Not the ideal. If you have WebSockets, you should use WebSockets. So WebSockets, again, it's a native thing built into Play Framework. Thank you very much. Not my doing, but thank you, TypeSafe and Play. Is that so you can have it come in, and then you have an iterate consuming the given input, and you can parse it out and do whatever you want, and then you can stream it out, as you can see below. So again, this is a simple example, but it kind of shows you the power of what Play Framework can do in just kind of straight out of the box. So some cool things about Akka that are pretty awesome is the ask and tell system. okay? So when you pass a message, there are two ways to pass a message. You can say fire and forget, which is an exclamation point, which is basically like, hey, handle this. So one cool thing that I use the fire and forget for are for sending emails. Right? I see no reason to have it stuck in my controller and having to wait and confirm that an email is sent out. I design my system in such a way that I fire it off and then ensure that once the supervisor gets it, the supervisor is 100% responsible for sending that email. If it was a financial service, and maybe a bit differently, but for my emails, I found that very doable and a good solution to my problem. So once you fire and forget it, obviously, as it says, you fire and then you forget it. If you add, so let's just say, so this, I have a little thing that says generate a report, right? There's a few other stuff, but ignore the clutter. I'll just zoom it in so you won't even see it. So in the report actor, you ask it a message, right, with the account and the transactions. And then you map the result, which is coming back. So in the report actor, okay, one thing to note that I probably should have mentioned before is how an actor generally works. So you make an actor class, you extend from the actor, and you have to only implement one function, or a partial function, which is receive. And receive is basically like a little switchboard in your actor. And you can have it handle as many different requests as you want, and then it will route them or do whatever you want with them, right? So, so you receive, and if it's a report request, basically what I did was that I generated the report, and then the sender sends back the report. Right? Easy enough. Because at that point, in the report actor, you fire and forget, you have nothing more to do. Now, sometimes, actually many times in my application, what I've done is that I feel the need to have this cascade, right? So I go all the way down to do some computations, and then have to relay actions all the way back up. There's actually a really cool feature that actually took way too long to find, that you can actually forward the original sender to your context, to your child actor. So it's a little more verbose, but you can tell your actor your message and the sender. So when in the new actor, you send it, you do sender, exclamation point, message, and it goes all the way back up. So a lot of times I find myself building these Akka trees in such a fashion that it kind of looks like a finite state machine. A lot of times they each handle their very little piece of knowledge, and if they do break, they report back to who they came from, and then you can handle it appropriately. So a lot of times the finite state machines actually have this really nice comeback loop, so I actually do end up sending the sender around a lot. Does anybody have any questions before I continue on a little bit? I don't know if that's a good thing or a bad thing, but we'll continue on. Another cool feature of Akka, and that they built out really nicely, is the Akka router. So let me find it real quick. So an Akka router, basically what it does is it allows you to simply use a bunch of different actors at the same time. So if you thought about what I was doing before, right? I created an actor, let's just say a transaction actor, right? And I passed the transaction actor to that. I passed a message to the transaction actor. That's literally only one reference of that actor, right? Now, that's not going to scale. I'm basically just having one worker thread do everything. That's very simple and won't be able to scale pretty much at all. So what you can do is you can have a router. So you create a router is really nothing more than a pre-made actor. So when you create your router, you create a actor in the system, right, with a router. So there's a bunch of different types of routing systems. You can actually build your own if you want to. But the smallest mailbox router is one that just makes the most sense to me. Basically, what it does is that it kind of queues everything underneath it, and if one actor is going really fast, or on one machine is going really fast, you can just keep on feeding it to it. There's round-robin routing, as well as other things. So a cool part about the router is it can be automatically resized, right? So instead of building some complex logic that'll help you scale and shrink your application as according to what it needs, you can actually have a lower bound and upper bound of a default resizer that'll help you use your resources most wisely. Times that have come in handy for me is during when I deploy a system for work, and during signup. There's a big load on signup, but we don't have a load anywhere else. It's actually really nice to be able to use that, use your resources only for your sign-up actors and your email services and stuff like that. So, and then as you obviously finish them, you can shrink them up over the course of time. Let me see what else is out there. So is there anything you guys are specifically interested in or have had roadblocks hitting with Play Framework at all? Anything that really confused you? Okay, so one thing that confused the hell out of me, personally, was how tedious it was to deal with JSON in 2.0 release. It was such a pain. I felt that a lot of it was very repetitive, and I would end up just creating these maps to objects that were, I felt that in other systems did very well dynamically. So Mandubian, Twitter handle, I forget his real name off the top of my head, created a really awesome macro that creates, that's literally one line of code. So you see this currency JSON format. You do JSON.format and the currency, and it will, during compile time, create your readers and writers. So that saves you a ton of time. It does not include the validation that you can get when you do your own, but it's a cause and effect that you kind of have to guess and kind of pick and choose your battles. Other really cool features in 2.1 is that filters, you can now intercept requests and handle them and kind of make sure that you can do them properly. This comes in handy for CSRF, for security, and other potential middlewares, so you can actually intercept your emails and handle them somewhere else if you want to. You can add more modularization. You can add routes in your subdirectories and kind of keep your application really modularized. Keep your admin section completely separate, whereas before you had to glue them in more than I would have liked. You can also do managed controller instantiation. Before you had to create an object that extended your traits. That was actually, well, you don't have to. You could use an object if you wanted to, but for testing, it posed a really difficult. It was really not flexible. So what they decided to do was that you can actually have, in your routes, you can choose to instantiate a new controller for your request, and it'll handle it for you. You can do require.js out of the box so that you can have a very JavaScript-heavy application run really quickly, and content negotiation, which is basically, oh, I want XML instead of JSON, sweet, let's use that instead. So those are all really cool features that are done in 2.1, and they're still improving it like every day. You can live on the bleeding edge and have it checked out. Otherwise, you can just stick with the steady release. Some resources that really helped me out, the documentation's gotten a whole lot better. I really encourage you to check it out, especially recently. If you are working with the bleeding edge, definitely go to the wiki on the Play Framework GitHub repo, because there's actually quite a bit of difference. and you'd be shocked at how much it kind of kicks you in the butt one way or the other. The samples as well. The Scala School by Twitter, that's a really cool kind of a resource they put together, if internet works. And if you have any more questions, feel free to contact me, mbseid at Gmail. I just do this stuff for fun, and I really enjoy it, and feel free to contact me and learn more. Any questions?
Could you talk about your experiences with A-norm at all?
Pardon?
A-norm? Could you talk about A-norm at all?
Okay, yeah, I really dislike it. So I got really spoiled. ORM is awesome. I have a post on my blog about how I actually use the Java ebean as my model and have it in a subdirectory. If you have it in the same directory as same project as your Scala application, the Scala gets compiled first, and none of your functions you have in your Java, because it does a lot of bytecode manipulation under the hood for Java, will get brought into your Scala, so it throws a whole lot of compile errors. So what I actually did, and it actually has paid off greatly in my design decisions, is create my model as a standalone play package, play project, and I can actually import that into my API and do that, so it's actually very modular. So I don't have to have one big monolithic application. I can move it around.
So talking about creating a separate project, you know, I'm interested in creating a project and then creating lots of different themes of that play application, like for, you know, reselling the core project to different clients, customized in different ways. So how would you go about, like with your models example, if you stick those in a separate package, or a separate library and get submodule it in or something like that, it seems like it would be a real pain to, you know, commit between different projects and push. And if you make a change in your template over here and you need to add a new field to the model, then you've got to go like recompile this separate project. And
so there's when I decided sub-projects, it might have been unclear, and I apologize for that. I actually don't do separate GitHub projects and a separate repos. What I have are SBT play projects. So you can actually do .depends on and have it depend on another project, and you can have it depend on as many as you want. So basically what that is, it'll actually recompile your other one first before compiling your parent application. So you'll see I have one play application at the very front, and it actually has nothing in it besides depending on a whole lot of submodules. And then you can actually like ensure that your compilation order is done right through that. Does that make sense?
Yeah. So when I do push to GitHub or whatever, I mean, have you worked with submodules, or is there a
I use submodules for packages that I don't control. In general, I haven't really worked with a big enough this scale that I have had to have more than one different project to do different things.
Okay.
So I really haven't done anything like that.
Okay.
One last feature I'd like to share with Play, if in the last 2 minutes I have, is the debug feature. So that has saved my bum so many times. To start it, you exit back to your shell and you do play debug, right? And it basically creates this socket 999 that you can use to debug your application. In IntelliJ, you can do run or edit configurations, create a new remote, change the port to 9999, apply, okay, run the debugger, and bam, you can throw breakpoints anywhere. Saved my butt so many times. So I don't know why I didn't know that earlier, but it's that easy. Any other questions? Hope you guys learned something.